Okay, so they're asking you to prove the theorem for this one, I guess. So if you've got z to the n equals 1, this becomes z to the n equals cis 0 plus k 2 pi. Right, and so then we've got, that will be cis k 2 pi. To get rid of the to the power of n, we take it to the 1 over n. Okay, and therefore we have k 2 pi on n. And of course the smallest one, that's going to be, so when k equals 0, that's going to be our smallest. And that gives z equals cis. Oh, no, that would be 1. So the smallest positive argument, so that's going to be when k is 1. Okay, so that would give us 2 pi on n. Carrying on, it's probably just what we've done before. The nth roots as is 1, show that. Yeah, I'm not really sure what they're wanting there, but basically, so this would be our smallest one, w squared, right? So that's when k equals 0, 1, 2, so that becomes cis 4 pi on n, and that's our next, I guess we should say 2 pi on n squared, right? And that equals cis 4 pi on n, and when k is 2, right, if we look at that thing before, when k equals 2, we get cis 2 times 2 pi on n, which is cis 4 pi on n. So we get the same answer. And I guess you can keep on doing it and then maybe do it for when k is n take 1. I don't know. That's a bit of a stupid one. So I wouldn't worry too much about question 4. Part 2, B part 2, stumped me a little bit, and then you looked at the solutions, and the hint was to look at the geometric sum of the geometric sequence, or it is a geometric sequence, and then of course we're adding it. So I had to go and look up and remember, right? The formula for sum of the geometric sequence is a, or t1, which is the first term, times r to the n take 1 all over r take 1, or you could have gone 1 take r to the n over 1 take r. Now our first term is 1, so that becomes 1. R stands for the ratio. W divided by 1 is W. The next term is W squared divided by W is W, and so on. So therefore our ratio is W. So we end up saying W to the n take 1 all over W take 1. What we're trying to do, show that it equals 0. Oops. Oh, that wasn't happy with that, was it? So what have we got? But W to the n is what? Because we've got cis 2 pi on n, that's our W, and then if we take that to the n, what do we get? I'm hoping this is going to be 0. Yes, it is, because you times that out, so it becomes n times 2 pi on n. Thank you, Demoivre. All over W take 1. And of course, the n's cancel out, so I have cis 2 pi. And what is cis 2 pi? Well, ladies and gentlemen, it is 1. And anything, or 1 take 1 is 0, and 0 divided by anything is 0. Huzzah!